Welcome to ScienceCover.com. In this session, we look at reflection. We look at why some surfaces reflect. We'll explore the reflection experiment, learn the rules of reflection, and understand how a periscope works. Before we begin, pause the video and complete the Do Now task. Let's check the answers to the Do Now task. Number 1, explain the difference between the longitudinal and transverse wave. Longitudinal waves vibrate in the same direction as the wave is traveling, whereas in a transverse wave, the wave vibrations are at right angles to the direction the wave is traveling. Part 2, explain the meaning of the term wavelength. This is the length of one wave in meters. Explain the meaning of the term frequency. This is the number of waves produced in 1 second. The amplitude is the height of the wave from the center to the maximum peak. And the time period is the length of time taken for one wave to pass a fixed point. Question 3 showed a diagram of a wave and asked you to label the wavelength and the amplitude. These are shown on the diagram on the screen now. Let's begin looking at reflection. Let's first understand why do some surfaces give a reflection but other surfaces do not. When we look at most surfaces at a microscopic level, they are not flat. Even a surface that looks and feels relatively smooth, such as this tabletop, are not flat on a microscopic scale. This means that when the light strikes the uneven surface, it bounces off in many directions. This means that the light loses its structure, and therefore no image or reflection is formed. Since most surfaces are microscopically uneven, most surfaces do not have a reflection. Only microscopically flat surfaces will give reflections, as the light keeps its order when it bounces off the surface. Pause the video now and complete task 1. Let's check the answers. Explain why you can see a reflection on still water but not on moving water. Still water creates a microscopically flat surface. When rays of light strike and reflect off the surface, they keep their order or their structure. This allows an image to be formed when viewing the reflected light. Moving water has an uneven surface. When the rays of light strike this surface, they are reflected off in many directions and lose their order or their structure. This does not allow an image to be formed from the reflected light. Now let's look at the reflection experiment. A standard practical on reflection will usually involve shining a ray of light onto a mirror. At the point where the ray of light strikes the mirror, we draw a normal. This is a dotted line at 90 degrees to the surface. We can then mark on the path of light reflected off the surface. We can now measure the angle of the light onto and off the mirror. The angle of incidence is the angle between the normal and the incoming ray. And in this diagram, that angle is 50 degrees. We can now measure the angle of reflection. This is the angle between the normal and the outgoing ray. And this angle is also 50 degrees. So the angle of incidence is equal to the angle of reflection. This is true for all rays of light that reflect off a surface. And so we call this the rule of reflection, that the angle of incidence is always equal to the angle of reflection. Pause the video now and complete task 2. Let's check our answers. Number 1, we had to add the labels to the diagram. The mirror is marked at the bottom of the image, and the incident ray is coming in from the left-hand side. The reflected ray is reflecting off the mirror and exiting on the right-hand side. The normal is the dotted line that is at 90 degrees to the mirror's surface. The angle of incidence is the angle between the incident ray and the normal, and the angle of reflection is the angle between the normal and the reflected ray. Question 2. What is the rule of reflection? This is that the angle of incidence is always equal to the angle of reflection. Now let's move on to look at the rules of reflection. The rule of reflection is true for all reflection, so the angle of incidence will always equal the angle of reflection. In this diagram, we can see an angle of incidence of 10 degrees, which means that the angle of reflection should also be 10 degrees. In this diagram, the mirror has been rotated through 90 degrees into the vertical, and we can see that the angle of incidence onto the mirror is 30 degrees. But using the rule of reflection, we can measure that the angle of reflection should also be 30 degrees. Pause the video now and complete task 3, drawing in the reflected ray for each of the diagrams. Let's check our answers. For question 1, the angle of incidence should be measured between the normal and the incoming ray. We should then match the angle of reflection to this and draw on the outgoing ray as shown in the diagrams. For question 2, we had to try to find the location of the hidden treasure. This is shown on the screen now. Now let's look at how a periscope works. A periscope is a device containing mirrors, which can be used to view your surroundings from a higher viewpoint. Periscopes are used on submarines to see above the water's surface without the submarine surfacing. Periscopes were also used in the First World War to observe enemies from the trenches without having to stick your head up over the top of the trench. A periscope works by using two mirrors placed at a 45-degree angle to the horizontal. In this diagram, we can see those mirrors labelled A. The light will enter through the top of the periscope. will strike the first mirror, travel down the periscope, strike the second mirror, and then pass to the observer's eyes. Now pause the video and complete task 4. Let's check our answers. Number 1, we had to add a light ray to the periscope to show the path of light to the observer's eyes. This should have entered through the top of the periscope, struck the first mirror, travelled down the periscope, struck the second mirror, and passed to the observer's eye. Explain how the periscope enables the observer to view the surroundings from a higher observation point. We know the light that was travelling at a higher point reflects off the mirror, angled at 45 degrees. This light then travels down the periscope, strikes the second mirror, which is also angled at 45 degrees, and passes into the viewer's eyes. The observer will see the image as though viewing from the height of the first mirror. Give 2 uses for periscopes. Periscopes are used to allow submarines to view above the waterline whilst staying submerged. And in World War I, the soldiers in trenches used periscopes to view enemy movement without having to raise their heads out of the trench.